and maybe make it available on your Moodle page so that you can look at it further. There are people that probably also had constraints joining today, and they can also have a look at this video when they get a chance. All right, so I'm going to share my screen. So what we're going to concentrate on in these two sessions is two parts. The first part, I'm going to show you how to deal with 1D NMR spectra, proton spectra and carbon spectra, and to see how to analyze them, how to process those spectra, and how to get a picture ready for your thesis that you're going to produce. Right? So this will come in very handy when a lot of you do projects in the next semester. And then the second part of this sessions are to tell you how to process 2D NMR spectra, right? So we're going to have a two-dimensional NMR spectra, and I'm going to show you how to process that, and how to get information on the structure, and how either to verify a structure or find a structure. A lot of you have been doing the basic stuff in second year and third year and honors. But this is now a real example that you're going to be faced with, and showing you how to use real examples. Right, so the first thing that you need to download Topspin 4.06, as I've indicated, and that's just a free software on the internet. And once you get to the software, you'll get to this page, right? And this has all the buttons on the top. So process, analyze, applications, and manage. So these are all your active buttons that you are able to use. So the first thing you want to do when you run your spectra on the instrument is get the files from that computer, right? So you can download the files either on a flash drive or a shared drive, but you need to get the files and know where you have access to the files. So in this case here, you see I'm clicking on these three bars, and I'm going to open a particular spectrum, right? So the one that I'm going to open now, so it goes to open, I'm going to open the NMR data stored in a standard format, right? And I'm going to browse my computer to see where they are. Now I've saved all of these here because it's your course. So I've got all the modules that I teach, and this is part of 751. So I've put these files here. I've got a whole lot of these files, and I've taken this from one of my master's students' theses that they produced. All right, so I've chosen one or two from here in order to show you how to process spectra, and I'm going to use this particular data set that I have. So this data set is for a particular compound. So these 5 experiments that you see, experiments 10 to 14, are experiments that were run on a particular sample after the student synthesized a compound, purified it, checked on NMR whether it was pure enough, and once it was pure enough, I signed it off, and she was able to run a full set of spectra in order to elucidate a structure. And you'll see a structure on my left here that I'm circling, and that's the structure of the molecule that she synthesized. Right, I'll show you how to put a structure in as well just now. All right, so I'm going to choose what to do. Now I know that experiment 10 was a carbon-13 NMR spectrum, experiment 11 was a proton, then I had a COSY, an HSQC, and an HMBC for this particular compound. All right, so those 5 different experiments, and we're going to start our discussion with the proton NMR spectra. So I click on the experiment that I want, and once I get the experiment that I want, in this case I'm choosing experiment number 11 because I know it's a proton, I click on display. You see the file name is 11 here, and I'm clicking on display. So you see what I'm getting in this particular case is a spectrum that I have, which shows you the different peaks in this molecule. Now, what I'm going to do today is show you how to process this and get this in line with what we need to get for our theses. Right, so the first thing you want to do is when you get this type of spectrum, this will appear on your screen, and you see that this has been processed before. So I was playing around with this as well. All right. Now I want to introduce you to these buttons here. So these buttons here allow you to move, and I'm using this particular arrow that you can see here. And you can see I can take it to the bottom, take it to the top, just by holding down my left button on my mouse. I'm staying on that particular grid, and I'm just going up and down by just using my mouse, right? And I'm putting it in a particular place, and you can see that when you started off, it was here, right? But all these sort of lines and these values blocked the spectrum. So I want to make it perfectly clear for anyone who's actually reading this, right? Now you'll see that I know because it's the structure here, I have only aromatic peaks. I've got some double bond peaks and more aromatic peaks in this particular molecule. So I know now that all these peaks that I'm looking at here are all impurity peaks. Now, perhaps the student should have actually gone back to the lab and purified it until such time that all these peaks have actually disappeared into the noise, right? So if these peaks disappeared, you know it's, so this sample here, I wouldn't say is 99% pure. This sample that we have here is probably about 85 to 90% pure, right? So it's not a real pure NMR spectrum, and I can tell that because of all these impurity peaks here. You'll notice that this is your aliphatic region of the spectrum, and you have no aliphatic peaks here. So you've got some aliphatic impurities in this particular sample, right? So I can tell that just by looking at the NMR spectrum. And later on, I'll show you about integration, and I can actually tell you that if I integrate a particular peak, I can probably do a calculation and determine what the percentage purity is just by using the integration in my NMR spectrum. Right, so the first thing I wanted to tell you was that I can use this button to move this up and down, right? And get a space that's clear of all the values so that I can see it pretty well. The second thing is, can you see this line that's going up, this black line that I have? So that's my line that I'm using to see what I want to work with. So if I click down on the particular line, so I'm pressing down on my right button on my mouse, and then can you see I'm extending it now to a certain range. And when I extend it to a certain range, you'll see that my cursor opens up. And what I'm doing now is opening up a certain range on my spectrum. All right. Now this range on my spectrum that I have here is concentrating on only the aromatic region. You can see I can even expand it a little bit further so I can see exactly what's going on in this particular spectrum. So I'm going to show you, I've processed this before, but I'm going to show you how to get the integration. So what you're seeing here is each of these values is the value of this particular peak. So 7.835 is the value of that particular peak. And there's 6 lines here. You're seeing the values of those 6 lines. There's 4 lines here. So this is a doublet of doublets of doublets. You're seeing the 6 lines for the doublet of doublets of doublets. This is a double doublet. You're seeing the 4 lines for the double doublet. This here is a double doublet, and I'll tell you why it's a double doublet in a second and not a triplet. But this double doublet that you're seeing has these 3 lines here and so forth and so forth. Right? So you have all these peaks in your NMR spectrum. Now, in order to get those, right, you need to have 2 commands, and you need to know about 2 commands. So I was in process, right, and I'm now switching over to analyze, right? But there's one thing that I want to show you quickly before I move over to analyze in the process part. Now, in many cases, as I said, you're going to use deuterated chloroform to run your samples. You might have DMSO, you might have methanol. Now, in that case, you need to know what the peak is and what the reference point is. So I'm going to start off by calibrating this axis. I'm going to pick on calibrate an axis, right? So in order to calibrate an axis, you need to pick a certain point, right? So I've picked the point of this particular peak. I know that chloroform has a peak for the chloroform peak, deuterated chloroform peak at 7.24, right? So you can see this is referenced properly. But just in case that's not referenced properly, so I'm just going to change this reference now to 7.37, right? And what you'll find is that now I have a completely altered spectrum. So just in case you get to a spectrum like this, right, the first thing you need to do is, okay, maybe this is my chloroform peak. I've just used a very raw example. I've exaggerated this a bit, right? But I want to now reference this. I know this is my chloroform peak. It should be at 7.24, but it's not at 7.24, right? So normally it'll be roughly in the region of 7.24. As I say, I've exaggerated this a bit, right? So I know that this is my chloroform peak. So I want this particular peak here to be at 7.24, right? You can see I've actually expanded it quite a bit, right? So this peak that I have here, I've expanded it quite a bit because I want to see it nice and clear. And then I go to calibrate my axis. And once I calibrate my axis, I click on a certain peak. It gives me a value of 7.36. That's the value I put in, right? But I want this to be at 7.24. So I click in my value 7.24, and I now have this particular peak at 7.24. You can actually see here. So I can go back. Now this square that you see shows me the full spectrum. So I go back where I was, right? So I can actually go right back to where I was and have a look at the spectrum again. And you'll see that the 7.24 peak is right here. All right, so that's my 7.24 peak. Now, so the first thing that you want to do is calibrate your spectrum. So I know now that every other peak is going to be referenced relative to this and to the TMS, because I referenced this chloroform peak relative to my TMS at 0.0. Right, so I have all of this. So I'm going to analyze now. I'm going to firstly pick all these peaks, right? So what I'm going to do when I'm showing you the peak picking, I'm going to firstly delete everything, right? So you have something that's a spectrum like this, and now you want to start picking your peaks, all right? So I want to start picking my peaks, and in order to pick your peaks, you need to use your mouse, click down, and create a square over that particular peak that you want, right? So once you create a square over that particular peak that you want, it will give you a value. And that value that you're seeing here is for that particular peak, right? So if I want to look at that particular doublet, this first part is that value, the second part is that value. If I want to take these two peaks here, I can choose both together. I can see 6 peaks here. I can either start to choose them individually, or I can choose the 6 together. I'll just choose the 6 together now. So that's for those 6 peaks. I can choose these 4 for the double doublet. This is my chloroform peaks that should be at 7.24. I can either choose to maybe let the reader know that it is at 7.24, or I can leave it out and cross this peak out and say CDCL3. And then there's this double doublet that you're seeing here, and I'm going to pick those peaks. Now you'll see it's a bit more difficult to pick peaks up in this particular setting. It's a multiplet that I have here, right? Now, I'm using the roller on my mouse and either increasing or decreasing the intensity of this particular spectrum, right? So I can decrease it right into the noise, and I can increase it way up. All right, I want it to be at a reasonable height, so this is probably a reasonable height that I can choose in order to process my spectrum. And you can see I've got some other impurity peaks. As I said initially, the spectrum is not very, very pure. All right, now if I'm going to choose this, I might say, okay, I want that peak and that peak and that peak and that peak and that peak, right? So I'm going to choose my square to encompass all those peaks that you see, if I stop here, I'm not going to get this peak, the small one down here. right? So I can either choose to do this, or I can say I want to also know what that small peak down there is as well, right? And I can choose those particular peaks, and that will give me the value for all of this. Right now, in many cases, all you're gonna, when you're reporting this data here, because I can't see clear doublets or double doublets or triplets or quartets or whatever it is, I'm just gonna say that the range between 8.09 and 8.15 is a multiplet in this particular region. Right, so the first thing that you did is learned how to peak pick. So I'm just gonna summarize that again. I go to analyze, I go to peaks. I click on this cursor here because that defines an area that I need to arrange that I can pick my peak in. So I click on that, and then I can choose peaks by clicking down on my button and creating a square over the peak, and that will give me a value. And once I've done that, I can save and return. If I click this button here, return, it's not going to save any of the changes that I've made, right? But if I click save and return, it's going to click everything that I've done, right? So I'm going to click save and return in this case here. And what will happen is the spectrum will now go back to the mode it was, right? So all these values here is a culmination of what we just did in the last few minutes or so. Right. The second thing I want to show you is the integration. So the first one was pick peaks, and the second one was integration. Right. So I've integrated this. I'm just going to clear this also. I've chosen this button here. I've selected everything like I did previously. I'm just going to delete the integration and start again for your purposes. So this is a spectrum. I've cleared all the other integrations that were on there. I'm going to integrate it myself and see what's going on. Now, before I integrate it, I want to know something about my molecule, because I want to know whether or not I've made what I said I've made, right? And if this integration doesn't agree with what I've made, I know either I have too many impurities, or maybe I have a mixture of sample, or maybe I have something else that I don't know what just yet. So I've made this particular molecule here. So I'm going to count my protons. Remember, this is a proton NMR spectrum. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 protons that I have. All right, so all these peaks here must equate to 11 protons. So what I'm going to do very intuitively is choose a resonance that I know should be at least 1 proton, right? And if I look at all of these here, it's a little bit ambiguous with regard to this structure, and it's a bit tricky with regard to this structure. I know something about this molecule that this should give me, these two should give me doublets with large coupling constants of 16 hertz. And that's this here, but I know that intuitively. I'll show you just now how to calculate those types of things, those coupling constants and so forth. So that's probably 1 peak, and I know that I'm getting doublets in this aromatic ring, ortho coupling to 8 hertz and meta coupling, 3 hertz and so forth, and 8 hertz and 3 hertz and so forth. But I'm going to concentrate on this particular resonance here. And before that, I want to show you, I'm going to click on one peak and then hold my mouse down and drag it to the other peak, right? And can you see that when I drag it to the other peak here, I can probably get a distance between the two, right? Now I'll show you that how to get a coupling constant just now using that particular effect, right? But what I'm going to do now, I just want to show you that again. Right, so I'm going to click down on my, so I'm not in any of the active buttons, right? I'm just out of the spectrum now, out of these active buttons now. I'm back in the process speak here. So I'm clicking down on one and moving to the other. And can you see my gray area showing me the distance between these two peaks here is 0.02 ppm. Right? And remember in second year how we calculate what the hertz are. There's a formula that we use because it's a 400 megahertz NMR spectrum and so forth. right? So this software calculates it for you and tells you that the coupling constant in this doublet is 8 Hertz, right? So I know that the coupling constant in this 8 Hertz here is probably due to maybe some ortho coupling between in this ring or that ring, or maybe this ring, right? I can see 2 cis-coupled protons here. So this is probably 1 proton. I'm just going to go back to where I was, to integrating. All right, so I know it was probably the spectrum here, right? So if I know that was probably 1, I'm going to choose to integrate this first, right? So all I did was I put my cursor on the left side and the right side, and I went through this, and I'll do it again just now for you. But what I'm actually doing by integrating this first is I'm using this as a yardstick because I know that this is 1 proton, right? So everything else is going to be in a multiple of this particular integration, right? So any other peak that's 1 proton will show as 1, 2 protons will show as 2, 3 will show as 3, etc., etc. Right? So that's what I'm doing here. So I now want to see what this big doublet is. You know, is it a big doublet or is it 2 singlets? You know, so I'm going to click on the left side, go over to the right side, leave my cursor, and see what the integration of that particular peak is. And you can see that the integration is almost 1 as well. So 1 there and 1 there should mean 1 proton and 1 proton. And then I'm going to choose this doublets of doublets of doublets. And you can see that this value of 0.983 is also very close to 1. This double doublet is also very close to 1. I'm not going to integrate the 7.24 peak, right? Because you'll find that, okay, let me integrate it for you. Can you see this value is off 0.54? And the value is off somewhat because this is not a proton that is concentrated or that is contained in your molecule. This is the solvent peak, right? So I don't want that particular peak, all right? And the next one I'm going to integrate is this doublet of doublets here. And you can see this double doublet that you see has a 1.837 value, and that 1.837 value is very close to 2 protons. All right, so if I count the number of protons I have so far, I've got 2, 3, 4, 5, 6. Right, and I've got 11 protons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 protons in my molecule. So which means that this multiplet here needs to be 5 protons in order for me to say that the sample that I have is relatively a good sample and has a relative degree of purity. And you can see this value of 4.67 or 4.7 is very close to 5, and that's the value that we are expecting. So I can now go ahead and say that I have 5 protons here, 1 proton there, 1 proton there, 1, 1, and 2. That's my 11 protons in my sample. All right, so I can go ahead now and save again. I've got my 11 protons here. I've got all my resonances that I can see nice and clear. I'm going to save that and return it and see what I have. Right, so I'm going back to the spectrum, and can you see now I have a nice spectrum where I can see things very clearly, and I can use this plus and minus buttons to zoom out and zoom in. You see I can zoom out here, or I can zoom in to see it a bit clearer, and that's the way we had it. So this is something now that you would want to publish, or you would want to put in your thesis, right? Now I'm going to just take any space in the spectrum. I'm going to right click here, and you'll see some parameters. And I'm going to say, go to Spectra Display Preferences, right? When I go to Spectra Display Preferences, there's a few things that I can do. Now you see what I've allowed this spectrum to display was the integral labels. And these are the integral labels that you're looking at the bottom here. It shows your examiner or your reader that you've integrated this accordingly. Also your peak labels. These are the peak labels, which allows you to see what the peaks are and what the chemical shift of each of those resonances are, right? I'm not going to choose all of those things. Right, these data points are just the points on this particular spectrum, so don't worry too much about that, but you can show that again. Right, so the two things that I'm showing here is my peak labels and my integral labels. Right, I can, if I want, sometimes you can also show the integrals. So the integral is that line. I'll show you what that means. So some people prefer, when I was very earlier on in my career, a student, I used to use the integrals. We didn't have all these other labels, so we used to use it. So the integrals are these here. So I can, with a quick eye, I can just see 1, 1, 1, 1, 2. And then if I look at this 2 and there, I can take my ruler, measure this and measure this and say, okay, maybe this is 5 based on this particular signal, or measure this as 1 and see what distance this is and then say that this is 5. So I can do that manually. These days, we don't need to do anything manually. Everything is computerized. But in the old days, when I was doing my PhD, we had to use a ruler and we had to use big pages to see what the distances were between these and how to calculate integrals. So it wasn't as easy as it is now. Right? But these days, I find that these integrals actually clutter your spectrum. So I don't suggest that students use those integrals. There's no need to anymore because you have the values. But it's entirely up to you if you want to. You've got that option. All right, so I'm just going to clear that again. All right, so this is a particular spectrum that you want, and as I say, it's good enough to publish now and use. So how do I get it in a way that I can put into my thesis or put into an appendix in my thesis? I'm going to now go back to my files here, and I'm going to try to export this. All right, so I'm going to click on export here, and it gives me a range of formats that you can export. Now, if I'm going to use it on my computer or computer programs, the PNG file is the best. Then you get your JPEGs, which will save it as a picture file. But in my experience and what my group uses is that we use the TIFF format. So the TIFF format creates things that are quite nice pictures that you can use for publishing in theses and appendices and publications and so forth. So I'm going to save this as 1H. So the file name needs to be a very reasonable and concise file name. So I'm going to say 1H, and this is a quinoline structure. So maybe 1H of the quinoline. And if I want to make it even more explanatory, I can say fluoroquinoline and put the extension in .tif. I'm using this particular file, this TIFF file, and I'm saving it. And I need to save it to a particular area. So I'm going to put it on my desktop for now. All right, so I'll just save it to my desktop for now just to show you what it looks like. And then once I put it in a particular file, I know where it's going to. I got my file name all set. I click OK. And this here is what we just created. Right, so this is a TIFF file that you just created, and you can now copy and paste this either into a Word document or a PowerPoint document that's good enough to have a presentation with this or good enough to put on in your thesis. All right, so I'll just show you very quickly, just in case I'm making a presentation to present to my honors class. And this is what I want to do, so I can just delete that. I can take that picture. And now I've got a ready-made presentation that I can actually have. So all I need to do now is put some words to this, but I mean, I don't even need to write anything here. I can just have this particular slide and I can talk through this slide in my presentation. Right, so that's one way that you can actually use that. The other way that you can do is put into your presentations. So if this was your presentation, you can say Spectra. And so you're writing things and you want to put that into your presentation. I can now insert that into my Word document. And then I can probably say here, figure 1. Right, so it's pretty handy to actually have that particular tool and be able to manipulate that tool in order to get what you want for your publication. Right, I'm going to stop there a bit and take some questions. I've done a lot with you in the last 40 minutes or so. So I'm just going to stop there. I'm going to project this and just run through some of the things that we went through, and then maybe take some questions after that. So I've showed you how to open a spectrum. I've showed you how to position the spectrum, delete all that's there originally, and how to create your own things. I showed you how to expand the region that you're working with. So you see we cut out all the noise, and I didn't work with any of the noise. I showed you how to calibrate a spectrum. I showed you using CDCL3 7.24, but this can easily be done for CD3OD and DMSO. These I said are the common ones. I didn't show you anything about phasing. Maybe I'll just show you some things about phasing just now. I showed you how to pick your peaks, how to analyze your spectrum and pick your peaks. I showed you how to integrate and count your protons. I didn't show you anything about, oh sorry, I did show you how to use your cursor and calculate your coupling constant. And I showed you how to expand appropriately and export files for the thesis. So I'm just going to go back now and talk to you about phasing a bit. I didn't need to do any phasing here because everything was phased already. So what you find sometimes that things are not really perfect like this, right? So I'm just going to try and see if I can just, right? So you might find a spectrum like this, right? So if you load your spectrum and you're not seeing something that's nice with a nice even baseline here, you're seeing something like this, showing like this. And I see in many cases, people, when they have presentations, they show spectra like this. And this shows that the student didn't really know how to process a spectrum because he left his spectrum like this, right? I've exaggerated here, right? But in many cases, it's not as bad as something like this, right? So this shows me that the student didn't actually look to get a smooth baseline, right? So I'm exaggerating a bit here because I want to show you how to fix it up, right? So this is a very bad phasing, right? And normally you don't get such bad phasing at the first attempt. But we can take something that's bad like this, and you see all I need to do, I've got this button 0, 1, and R, right? And this actually shows you it's my right phasing. So I click on my 0, and I can go up and down on my button of 0, right? You can see I'm just going up and down clicking down on my mouse on the left side of my mouse, the left click, and I'm controlling this. And I control it until my baseline is nice. Can you see now my baseline is nice and steady, nice and flat. And now I've properly phased my, my spectrum. And I didn't need to do any of the right clicking. You see that's not really the problem here. The 0 portion was the problem. So the 0 and the 1 is more like a fine coarse and so if you're looking at through a microscope, you get your fine tuning and your coarse tuning. So your 0 is normally like your coarse tuning that you have. And you can see you can fix up most things by using that. Sometimes if it doesn't come right, you might need to use the 1. But in most cases, you can use that. But play around with the 0 and the 1 until you get a nice baseline. So that's nicely phased and nicely corrected. All right, so I can either save and return, or I can just return. I'm not going to save and return because the phasing was right when we started off with. I just messed it up to show you how to correct it. All right, so I think I've now covered everything that I needed to cover in this first part of the session. I'm going to stop there and take some questions. All right, is there any questions from anyone? You can either use the raise hand function, or you can just speak out if you want. We've done a lot, right? It's a lot for you to take note of, but I've also got this video that I'm going to put up for you, so if you missed anything, you can actually go back and have a look. Langalishle and Leila, you have a question?
Yes, sir. I had a question that was with regards how do you load the spectrum? But you said that you'll upload this video on Moodle, so I can just check it out then.
Sure, it's easy to load a spectrum. I can just run that through quickly with you again.
Okay.
Right, so generally what I said initially is that you would have run the sample on your spectrometer and you would have got a data set. And once a data set gets created, you can either go with your flash drive and collect the data, or some people don't like, students putting flash drives into their instruments or computers. They put the data on a shared folder where you can go remotely and get the files. Right, so you need to go to these three buttons that I'm showing you. That's your menu. So there's three buttons actually the menu, and go to open, and it'll come up with this tab here, open your NMR data, right? And I'm choosing a file chooser here because I want to browse my computer to see where the data is. I'm browsing my data, it's going straight to this file, but just in case it wasn't here, right? I know where this is sitting, it's sitting in my my folder. So this is where I have all my lectures that I teach. It's sitting under one of my modules. This case is 751. And 751, I've got all the resources that I need to teach this course. So this is my one data set. So the April 17th, I made a copy here to play with and show you how to use Topspin. This is the real data from this thesis, but I'm going to use this copy to show you how to take things. I'm going to click on that data set, and in that data set, I have 5 experiments, and I can choose any one of these experiments, right, to actually look at. So that's how to open up a spectrum. Any other?
All right. Thank you, sir. So,
Sure. Any other questions from any? All right. So that's how you process a proton spectra. I'm going to quickly do a carbon-13 NMR spectra, and then we're going to take a break, right? So I'm just going to share again. All right. So I analyzed spectrum or the data set 11. I'm now going to look at data set number 10. All right. And display data set number 10. Using the same strategy, going to open, find the files on my computer, and so forth, right? So this is actually the data set number 10, and this is a carbon-13 NMR spectrum. It's actually quite nice, but normally it's something like that, right? So it might be something like that. And I want to now, as I said, it can be, I want to take it up, and you can see what I do when I clicked on that. It took it to the middle of the spectrum, right? So the midpoint of the spectrum had the baseline in there. Now, what you'll notice here that I have some peaks pointing down and peaks pointing up, right? Now I'm just going to just mess this up a bit, and then I'll show you how to fix it up when it's messed up, because sometimes it's not as perfect as this, right? So just in case you came to if you loaded the carbon-13, you saw this type of thing here, right? Now we have 2 types of peaks here, up and down, and normally the CH3s and the CHs, right? All your protonated peaks. So CH3s and CHs are protonated, they appear up, right? And then the CH2s, which are also protonated, appear down, and the singlet appear down, right? So those things appear down, and the CHs and CH3s appear up. Now, normally your protonated peaks are more intense than the non-protonated peaks. So in this case here, I'd see that these are all my Cs, my quaternary carbons, and these are all my protonated CHs that I'm seeing for the spectrum. So there's something wrong here, because this should actually be pointing up, not down. So this is an inverted APT. So this is called an APT spectrum, right? So it's not just so carbon spectrum will have all the carbons up, but the APT spectrum will show the carbons pointing up as CHs and CH3s, and the singlet carbons pointing down. So I've messed this up for you because it's so to make it wrong. So you need to fix this. So in order to fix this, I need to adjust the phase of this again. So I'll go to adjust phase in my process window. And I need to invert this by 180 degrees, take this to the top. So if I click on that, you'll see that my CHs are now on the right part of the spectrum, and my Cs are now on the bottom part where it should be. I don't have any CH2s in this particular spectrum, right? You can look at my structure, there's no CH2s here, so I'm not gonna, but if I did have CH2s, it would be pointing down. All right, so this is my carbon-13 NMR spectrum. And if I look at my structure, I've just got aromatic peaks here. I've got a carbonyl peak. You know, your carbonyl peaks roughly around 200 or so, right? Probably this one here. So I'm going to look at peaks, and then I'm going to expand this region again, all right, from there to there. Before I expand that, can you see this peak that we have here? Now that is your solvent peak, right? So the CDCl3 solvent peak is here again. And you can calibrate on that peak, it's about 77.0, right? So if I expand here, you'll find 3 peaks, right? So 1, 2, 3. So those 3 peaks for CDCl3, all right? So that's your carbon that's being split. Now, why is it a triplet here? It's a triplet because of the protons that are coupling the carbon, right? So that's why we're finding it here, right? So that's your solvent peak that we're not going to worry too much about because it's just a solvent peak, but that should be roughly about 77.0. You can see it's calibrated properly, but if it's not calibrated properly, again, we can go to calibrate that particular peak, right? Just like how we've done it previously, you can go and calibrate your axis, right? So I can calibrate my axis, click on this middle peak here, and give it a value of 77.0. You can see it's correct in this particular case. All right, so I'm not going to concentrate too much on that. You can see your spectrum is inverted again. I'm just going to adjust my phase, take it right, and then go back and save it. And you can see now that you have your spectrum in which to work. Now, I want to work only with this area here. So I've expanded that particular area that I want to work with. And you can see that once I've expanded that area here, I can also roll my mouse like I did before. And I can roll my mouse and increase or decrease all of these, all right? Now, what I'm going to do is show you how to analyze this particular spectrum. So the next part of the session is going to be looking at this carbon-13 NMR spectrum in correlation with the structure, and we'll see that everything is not as nice as it seems because I have a fluorine spectrum in here, and this fluorine actually will couple the carbon, just like I said, you know, in the chloroform peaks that you saw, it had coupling in it. So this fluorine will couple the carbon into doublets that you'll probably see in the spectrum as well. But before I analyze this carbon spectrum with you, I'm going to take a short break because we've been going on for about 45 minutes. So it's now 2:53, and we'll come back at 3 o'clock for the next part of this session. And in the next part of the session, I'll show you how to analyze this carbon spectrum according to this molecule. All right, so I'm going to stop my sharing there. Take any more questions before we take a break. Is there any questions that you have before we stop here for a break? I don't see any hands. All right, so we've got about 5 to 7 minutes before 3 o'clock. Make yourself a cup of tea and then come back at 3 p.m. and then we'll start again. All right, so I'll see you just now.